Hello students, now welcome to the new module of our chapter called Magnetism. And students, in this particular module we'll be learning what are diamagnetic materials or what are diamagnetic substances. Now students, in the previous module we have already learned about the classification of substances, and that too classification was done on the basis of magnetic dipole moment of an atom. Right? If the magnetic dipole moment of an atom was equal to 0, then the substances or the material was classified as diamagnetic material. Right? At the same time, if the magnetic moment of an atom was not equal to 0, then the substances were classified as either paramagnetic or ferromagnetic. Right? So we were having three categories: diamagnetic, paramagnetic or ferromagnetic. For diamagnetic, magnetic moment of an atom is equal to 0, whereas for ferromagnetic and paramagnetic, the magnetic moment of an atom is not equal to 0. Right? And in this particular module, we'll restrict our discussion on a term called as diamagnetic materials. Right? So let us start with the module. Now if I want to define diamagnetic substances, so I can define it as a substances which are weakly repelled by the magnet are called as diamagnetic substances. So if I'm having a bar magnet and a diamagnetic substance, you can see this diamagnetic substance is getting weakly repelled by the magnet. Right? Now students, we have already calculated the magnetic moment of an atom in the previous module. And how to calculate it? We can calculate it by the vector addition of magnetic moment of all electrons, or I can say magnetic moment of an atom. It is equal to summation of magnetic moment of all the electrons. Now what happens in case of diamagnetic substances? Magnetic dipole moment of all the electrons cancel out each other, as a result of which net magnetic moment of a diamagnetic substance is equal to 0, or I can say in diamagnetic substance, magnetic dipole moment of all the electrons cancel each other, as a result of which resulting magnetic moment of the atom is equal to 0. Right? Now students, this is a very important point, kindly note it down. Now let us see the behavior of diamagnetic substance when it is placed in external magnetic field. Whenever a diamagnetic substance is placed in external magnetic field or external field is applied to diamagnetic substance, what happens? Those electrons which are having magnetic moment in the direction of field, right? So those electrons which are having magnetic moment m in the direction of field, these electrons will slow down. And those particular electrons which are having magnetic moment, let's say that magnetic moment is m dash, in the opposite direction of field, these electrons will speed up. So those electrons which are having magnetic moment in the direction of field will slow down, and those electrons which are having magnetic moment in the opposite direction of field will speed up. Right? And because of these two parameters, because of slowing down and because of speeding up, this diamagnetic substance gains a net magnetic moment in the opposite direction of field. Right? So what happens? Whenever an external field is applied to diamagnetic substance, electrons having magnetic moment in the direction of field will slow down, and those electrons which are having magnetic moment in the opposite direction of field will speed up. And because of this, it gains a net magnetic moment in the opposite direction of field. And due to this, the diamagnetic substances are weakly repelled by the magnet. Right? So let us summarize. So I can say for diamagnetic substance, magnetic moment of an atom is equal to 0. And second point is, whenever external field is applied to diamagnetic substances, they develop a net magnetic moment in the opposite direction of field. So students, in this particular module, we'll simply restricted our discussion on diamagnetic substances. In the forthcoming module, we'll be learning about the properties of diamagnetic substances. So I'll see you in the next module. Till then, keep learning. Thank you.